Hello everyone. In this presentation, I'm going to present our student library management system. First of all, the aim of this project is to create a database system for tracking books and students in library. The database will store information about the books, students borrow book, dates when books are borrowed and returned, and fines for the late returns. The first step of the project was to design the database schema and create the necessary tables. This included defining the columns for each table and establishing relationship between the tables using for each case. The second step was to create views and triggers to automate certain tasks and provide different perspectives on the data. For example, a trigger was create the decrement, the books count, when a book's borrowed, and view was create the display of available books. The third step was start the procedure to retrieve a list of available books. The third step was I'm saying the final step was to test the database system to ensure that it was working correctly. Okay, I think we can test our database system. Oops, we stop that, and okay, we can test our codes. I run these codes, and the output of this code is our first page. I want to add the student name. Okay, the student ID. Okay, this is my ID, and new student. Oops. Okay, when I look at the table, I can see my name, the last column. Okay, our system is working correctly. The book borrowing part, the fine part, and the last one is the taken dates. Okay, I returned our codes. This is all codes. Okay, if I go back to our relationship schema, this is our relationship database schema. These are the created the 5 columns, the SQL commands that create several tables and views in a database. The first block of code creates a database and creates a table we call books with the 5 columns: book ID, book name, writer's name, page count, and book count. The book ID column is an identity. Also, it's a primary key. The second blocks of code creates a table we call the students with 4 columns: student ID, student name, student surname, and student school ID. Okay, the student ID is identity, also primary key. Also, it's marked as not null. The third block of code creates a table we call the taken books with 4 columns. Taken ID, book ID, student ID is given. The taken ID column is an identity, also primary key. Design the primary key. The book ID and student ID columns are both integer columns, and they are designed for each key. Yes. The fourth blocks of code creates a table we call the taken dates with 4 columns: a taken date ID, taken date, given date, and taken ID. The taken date ID column is an identity, also is primary key. The fifth blocks of code creates a table called find with 5 columns. Also, the find table is likely used to store information about fines that are imposed on students for returning books late. The is paid and paid amount columns are used to track whether the fine has been paid, and if so, the amount that was paid. The student ID and taken date ID columns are used to link the fine to a specific student and a specific instance of borrowing book. Okay, I think this is end of the presentation. These are SQL queries. Also, I explain them beginning of the video. Okay, actually this is our report. I want to present in this last one. I want to show again our output.